All right, so 4.1 is talking about sampling and surveys or sample surveys, mostly about good sampling and how to do good sampling and how to do bad sampling and what bad sampling looks like and what good sampling looks like. So first let's talk about some different types of studies. We got a sample survey. This is just a questionnaire sent out to a subset of the population to get opinions. Maybe we want to know what kids in our class think about maybe the prom theme or something. So you send out, maybe don't want to survey everybody because it would take too long, so you just send it out to a subset of the population, maybe like 50 kids, to get their opinion. With the idea that those 50 kids, their opinions should kind of reflect the opinions of all 450 kids, right? Prospective study, individual subjects are followed over time, and data responses about this is collected as characteristics or circumstances change. So a prospective study, you kind of survey subjects, you pick the subjects right away and then you look at them over time as the future elapses. A retrospective study is individuals are sampled and information data is collected about their past. So we survey people and we ask something about what happened to them in their past, like what happened to you last year. Did you get sick last year? So in a prospective study, you would say, okay, I'm going to study you. Let me know if we're going to see if you get sick this year. Whereas a retrospective study, we would survey somebody and say, did you get sick last year? Observational study, individuals are observed without trying to change the environment or conditions. We're just observing what happens. We're not trying to manipulate them or their environment. An experimental study is where we impose treatments. So if we were like wondering if a vitamin C can reduce a person's chance to get a cold, we would give them vitamin C, and maybe we'd give another group something that's not vitamin C, like a placebo, and then we would see if the vitamin C group got sick less than the placebo group. That's an experiment. We're going to talk about all of these. Mostly we're going to talk about observational studies, kind of sample surveys and observational studies in 4.1, and then good experimental design in 4.2. That's kind of our goal. So the population in a statistical study is the entire group of individuals we want to learn information about. So the population would be every subject of interest. A census would be a data collection where we collect from every individual in the population. Now, you've probably heard the word census. Every 10 years the US government tries to do a census, but of course they don't. They don't survey everybody. Some people are surveyed more than once, and a lot of people, like homeless people and minorities, are not surveyed at all. But they try to do a census. Okay? A census is where you collect data from every single person, a true census. And then a sample is a subset of the individuals from the population that we want our data. So we're going to sample, maybe we have 450 kids at our school. We're going to take a sample of 50 kids. Okay, that's a subset. So statistical inference is using information from a sample to infer or draw conclusions about the larger population. Statistics is quite literally, if the true mean word length in that passage is 4.9 and I get a sample mean of 5.3, this 4.9 is unknown. I only know this 5.3. The question is, how good is it? How close is it likely to be? Can I make some inferences? Can I say the average word length is bigger than 5? Stuff like that. Okay, so without sampling, if there was just census, if we only took census data, collected census data, there would be no reason for statistics. Okay. So a statistic is a number that describes a characteristic of a sample. I always say it's a measure from a sample. Measure from a sample. For example, the sample mean. Whereas the parameter is the measure from the population. Okay? So if you take a census and calculate the average, you have a parameter. If you take a sample and you calculate the average, so the measure can change. Sometimes the measure could be the average, sometimes it could be the standard deviation, it could be the median, it could be a percentage. It could kind of be any measure you want. It could be the max, the min, the IQR. Any summary measure, if it's from a sample, it's called a statistic. If it's from the population, it's called a parameter. Okay? So we want to denote the difference between these values so that we can study them. We want to know which one is which, and we come up with different symbols for each. So for the population mean, we use mu. The sample mean, we use x bar. Okay, we've talked about this before, but now you really need to kind of be able to remember it and utilize it. Sample standard deviation, population standard deviation sigma, sample standard deviation s. Sample proportion p, population proportion p, sample statistic p hat. Okay? And then these other ones aren't used as much, so we don't have special notations, but we would just say population median versus the sample median, population IQR versus the sample IQR. The fact that we have special names for these three kind of tell you where we're going to be spending our time this year. Okay? Those are going to be the most important values. So the sampling frame. The sampling frame is a list of the items or people that have a chance to be chosen for the sample. Okay? And you might be thinking, well, wait a second, doesn't that sound like the population of interest? Yes, it should. But here's the issue. Sometimes whenever we're sampling, sometimes our sampling frame, the people that could be selected for the survey, for the sample, is not necessarily the same as the population of interest. Okay? And that's where we're going to run into some major problems. Okay? We want the sampling frame to be exactly the same as the population of interest. But if those two things don't match up, that's when we can sometimes run into problems. Okay? Let me just give you a little for instance. If I was taking a survey of our high school kids, let's just say there are 450 kids in the upper school. Okay? I'm going to take a sample of 50 kids. So I come to school on a given day, and so on a given day, let's say everyone is in the auditorium, and I randomly pick certain seats in the auditorium, at the GPAC during assembly or something. So the sampling frame would be all the kids that were in the GPAC on that day. But is that the same as the population of interest? My population of interest is every kid in the upper school. But maybe there's only 430 kids in the GPAC on that given day. Why might there be 20 kids gone? Maybe they were sick. Maybe there was a athletic event going on. Maybe it's in the morning and the seniors don't think they have to come to school because they're special. No. For whatever reason, there might not be all 450 people in there. So this is my population of interest. This is my sampling frame. And this is my sample. So does this create a problem? Well, it creates a problem if I'm asking a question where the 20 people that are missing from this population may have different opinions about my question of interest. For example, if my question was, if I wanted to estimate how often do you miss school, like on average, how many days are you absent from school? Well, the 20 people that are gone, they might have, on average, more absences in a given year, like let's say maybe 8 or 10, than the people that are in this group here. So then my sample, because my sampling frame is different than my population, my sample statistic, the average number of days that the kids are gone, might not be a very good reflection because of the type of people that were missing from my sampling frame. Okay? So this creates a big problem. Okay? In a perfect world, our sampling frame would just be the population of interest, and then there will be no problem. Or there will be less of a problem. There might be other problems, right? All right, example. Weight of high school football players. We are interested in finding the average weight of all U.S. high school football players. We take a random sample of 100 players in the Houston area. So you can already see we're interested in the average weight of all United States high school football players. We take a sample of 100 players from the Houston area and find the average weight is blah. Average weight of the 100 players is 196 pounds. Suppose the weight of all high school football players in the country is 189 pounds. Identify the following. Population of interest, all U.S. high school football players. Sampling frame, all Houston, well, assuming that they actually could get all the Houston players, all Houston players, I guess we could say high school football players. But it might not even be that. Like if there were certain high school football players, like maybe there's a small school that didn't have a chance to get selected. I don't know exactly how they did it, but we're going to just assume that it was all high school players. What's the statistic of interest? So the statistic that they calculated was, we had a sample of 100. So the statistic, the measure from the sample was a sample mean. They calculated a sample mean, so they calculated an X bar and they got 196 pounds. The parameter of interest is I don't need to say parameter, sorry. By the way, the statistic of interest was the sample mean, okay? The parameter of interest is the population mean. And that was, according to this, 189. Now, in reality, we rarely ever know what the true population mean is, right? We just take our sample, and that's all we have to go on. Okay? So notice that the sample mean was different than the population mean. Okay? All right. Example, drinking and driving. So, drinking and driving. In order to determine how many adults of legal drinking age in their city feel about whether drinking and driving was a problem, researchers waited outside of a bar that they had randomly selected from a list of all such establishments. They rolled a 10-sided die. It came up a 4. So they stopped the 4th person who came out of the bar, and then they surveyed every 10th person after that and asked whether he or she thought drinking and driving was a serious problem. So identify the population of interest. In order to determine how adults of legal drinking age in their city, so all adults 21 plus in this city. Identify the sampling frame. So the population of interest is who you're interested in. The sampling frame is who could have been selected. So they had a list of such establishments. So this would be the people at the bars on this list on the night of the survey. Now you might say it was only the people at the bar that they actually selected. Well, no. They had several bars. Maybe they had 50 bars, 100 or I don't know, 20 bars, right? And on the night of the survey, anyone at any of those bars could have been selected, because we're going to randomly pick a bar. We pick this bar, and then we randomly take the 4th person and every 10th person after. But if there was a person at this bar, they could have been selected if that would have been the bar, and they would have been the 4th person or the 14th or the 24th. Now, if there are other bars that are not on the list, like maybe some small little pub type of place, then that bar would not be part of the sampling frame. Or if you're at home at night, or if you're at the grocery store, or if you're at the church, or if you're at the movies, none of those people would be selected, right? Could this lead to a problem in the study? Yes, of course. Why? Well, we're getting information only from the people that go to the bar. We're asking a question about whether drinking and driving is a problem or not. I don't think it's too far of a stretch to believe that people that go out to a bar at night may have, on average, different opinions about drinking and driving than somebody that is not at a bar that night. So yes, the people at The bars may have different opinions about drinking and driving than the people not at the bars. Okay? How can we fix this type of problem? We really just need to make our sampling frame equal to our population of interest. Okay, now it's not always easy, but you know, don't survey people at the bars. You know, so the question is, how are you going to survey people? I don't know. Maybe you could get a voter registration list or something. But then, if you do that, then you're not going to get. You know, what about people that aren't registered voters? You know, so it's not easy, but that's what needs to be done. We need to survey. We need to sample from everybody. We need to sample from all people in the population. Otherwise, we're going to have problems. Okay? All right.